Okay, so it should be there. Let's double check. Did all this already, but yeah, we're good. So, okay. We'll see who's here, who's not here. And Damian Acuna. Adir Aguilar. Okay, Cesar Ayala. Brian Blanco. Okay, Eric Bueno. All right. Steve Calderon. Jasmine, it looks like Catalan, sorry. Jonathan Cervantes. All right. Ivy Cohen. Okay. Christian Cortez. Christian Cortez. Emmanuel is here. Okay. Alfredo Gonzalez. All righty. Cindy Gonzalez. Cindy Gonzalez here. Samantha Han. Okay. Blanca Hernandez. Okay. Muyan Jiang. Maverly Leva. Shirley. Hector Lopez. Okay. Jesus Lopez. All right. Hung Lu. Julie Luna. Is Julie here? Victor Martinez. Okay. Julio Morales. Julio here? Alejandra Moreno. Alejandra. Lauren Munoz. Is Lauren Munoz here? Georgia Ortiz. All righty. Michael Rangel. Okay. Angela Rodriguez. Cynthia Rodriguez. Priscilla Serrano. Priscilla. Looks like Panuat. Okay. Sarah Valdez. Okay. Astroberto Valencia Hernandez. Okay. Andres Vegas Ramirez. Andres Vegas Ramirez. Ruben Vasquez. All right. Brandon Wu. Lauren Wu. Okay. Alice Yu. Antonio Zhang. Yang Zhao. All right. And I think we had Ruben Lugo. Is that right? Is Ruben Lugo here? Okay. Sorry, Roger Lugo. Sorry, not Ruben. Roger here. Sorry about that. We got you here. Now, what about Julio Morales? Julio Morales here. All right. Looks like we're covered. And here we go. It looks like we're good to go here now. Let me go to the browser. I got to find out and remember everything here. Going to the browser. This is Math 241. And we're going to go here to the worksheets and videos. So I'm going to say to you, take a look here. Geometry Review 1. Of course, you guys know or should know that, the kind of prerequisite for trigonometry is like algebra and geometry, meaning you got to have some of those kind of ideas, right? Algebra and geometry. And so here's kind of a review here. Remember we say this is kind of like the S version of this 241 course, right? So you have some review under the S version. And I put that here in the comment section for you guys here so that you can actually reference it. But if you said, hey, where do I get a copy? Well, go back over here to my website, right? Under this worksheets and videos titled Geometry Review 1. So, at home or on your phone, whatever, you guys can take a look at that or print that up. But I'm going to kind of talk about this idea here. Let's see if you guys understand and remember some fundamental ideas in regards to geometry and algebra. It's kind of a review, right? So, okay, ladies and gentlemen, let's go now take a look here. see how things go. And I'm going to be now in, I was going to go, okay, the iPad is in the lower left corner now. So you guys can see that there, hopefully. Okay, so this is Geometry Review 1. Now, does anybody know, what does this actually mean here? There's a symbol down here, right? Do you guys know what that means? Well, yeah, that little square, even though I drew a circle, maybe I should do a square, see if I can. Yeah, see that little symbol? That is like a corner, and that represents a 90-degree angle, if you guys forgot about that, right? So a 90-degree angle, it's also known as a, what's the phrase for any angle that measures 90 degrees? It's called a right what? It's a right angle. Okay, that's the language we use is right angle. Okay, you guys okay with that? Right angle. Then, a little bit of geometry review. It's kind of like, I would say, the cocktail party language geometry course, right? Not very formal. What do you think they're trying to communicate to you here? They have a 2x here, and then they have a what? An x minus 5 here. Is that true? Do you guys see what I'm saying? So what are they trying to communicate to you by this picture? What do you guys think? It's probably good to read the instructions. What do the instructions say? Determine the following what? What's this word? Complementary angles by solving for x. So they want us to find, they use that word complementary. So what do you guys think? If you see the word complementary, what does that even mean, complementary? Complementary angles. You guys know what that even means? Anybody know? Yes. What's the definition of complementary angles? Okay, let's kind of write something like that down. Okay. Okay, so here's what I'm going to say. I could do it a couple of ways here. I'm going to say, let A and B be two angles. Now, if it's beginning algebra, or if I should say even geometry, they don't like to say A and B. Sometimes they're going to say what? Alpha and beta. They change the letters to Greek letters from capital, this is actually lowercase alpha, I think, and lowercase beta, by the way. So they change the letters to Greek letters. Is that right? Is that such a big deal? Not really. It's a symbol. It's a letter, right? So I'm just going to start off by saying you have two angles here. Okay? So with those two angles, I'm going to give you a definition, and here's your definition. Okay? We say two angles. And what are they called? Alpha and beta. Or complementary. If what? If the sum is equal to what? 90 degrees. And then I'm going to put this other word in here, okay? I'm going to put this word called adjacent. So I'm going to say, hey, two adjacent angles are complementary. If what's the deal? If when you add them, what should they be? 90 degrees. This is the criteria. So if I add two angles together, alpha and beta, and the sum is 90, what are they called? Complementary angles. Okay. Now, the classic picture of that, like if people were to draw a picture of that kind of thing. What's that? Well, they have to add up to 90 degrees. In other words, they're next to each other. Okay? And sometimes some books will put that line. They'll say, hey, here's your first angle called alpha. And then they'll put a couple of these other lines. And then they'll say, here's the second angle called beta. So you know, oh, there's two angles. But what do they really need to do? You guys remember? You need what? That symbol. All right, you guys okay with that? You need that symbol. Okay, so now you're good to go. And you say, well, what does that really mean for me? Well, it means this. It means you have the first angle right here. It means you have that second angle right in here. And if you add them and it's a corner, remember they're adjacent, they're right next to each other, then that's a complementary angle situation. Okay? You guys remember, nothing like some coffee and sound effects to wake us up. Is that right? Okay? You guys are going to wake up. Anyway. Okay, complementary angles. What's the other idea associated with this? You don't just have complementary angles. What else do you guys have? Supplementary angles. Yeah, so I'm going to say here, give you guys another definition here, right? So I'm going to say, we say two angles are what? Supplementary. Okay? If, and you say, what do you mean the two angles to adjacent? What does adjacent mean again? Do you guys remember what adjacent means? It's a fancy word for what? Nope. The word adjacent. Next to. Thank you. Adjacent means simply right next to. Like directly next to. Okay? Like if you had a neighbor, not somebody down the street, but next door. Okay? Next to you. If what happens? When are they supplementary? If you add them and they equal what? 180 degrees. Okay? So you say, what do you mean? You can add angles and it equals 180? Yes. What does it mean if they're 180? Yeah, do you guys remember what an 180 degree angle measures? That's a straight line. And it's kind of, you should just say line, but whatever. And you say, well, what about this 90 degree angle? Well, that's a right angle. That's like a corner. So this is some geometry review S241S stuff here. Want to remember some of this stuff. And the picture. A lot of times, you know, a picture's worth 1,000 words. So here's that alpha, here's that beta, and sometimes I'll put a line here. Got a couple of lines there. So you got this alpha, you have this what, beta, and what's supposed to happen? When you add them, it's 180. That means there's a straight line there. All right, you guys remember this stuff here? Okay, this is important stuff. Okay. Bless you. Bless you. All right. Now, let me ask you guys this question here. See if you guys remember. Right? If I write down this, just reading that left to right, what does that actually mean? Yeah, you have this little scripted L. What does that stand for? Right? This thing, L, this is called line 1, right? Line 1. The subscript tells you there's two lines, the first and the second line. And what does this mean? No, that says line 2. And what does that symbol mean again? They are parallel. What does parallel mean? They never what? Intersect. Is that right? So we have these symbols here, if you guys remember. This symbol is a very famous what? Parallel line symbol. Okay, we're reading it left to right. And again, in some ways, and I'm going to run out of colors, but we could say here, line 1, there you go. Line 2, there you go. Line 1, line 2, they're parallel. Okay, so you say, what is the picture? You know, here's a picture. just your paper. The paper itself has parallel what? Lines. Isn't that amazing? So you guys actually know what parallel lines are, kind of, right? Because your paper, you've been looking at it your whole life. Oh my God, everybody says math is hard. You've been looking at it your whole life. Parallel lines, right? So this is going to what we call L1 and what? L2, because there's two of them. So first line, okay? Then you got the second line, all right? You guys okay with that? So you go, wow, is that what they mean by parallel lines? Yeah, and they could be diagonal, they could be any way. I just wrote them horizontal, right? And let's see if anybody remembers this. If I add a third line, I'm just going to call that L. If I add a third line now, what are you guys looking at? Gotta find out. There we go. What is it called now? Anybody remember? Anybody take geometry before? Huh? What is that called? From geometry. Oh, stressful. Yes, what's the name of that? Nope. Anybody know? What is this? Huh? What you're looking at is something very, I'll color this gray because I added a third line here, right? Just so you guys know. And I just call that L. I can call that L3. Or I could call it L, no big deal. But this is actually known as something here. It's an important figure. Just looking at these three lines where you need L1 to be parallel to L2. This is why we put that criteria. Yes. Thank you so much. I'm going to bring a bag. I'm going to bring some Flamin' Hots and start passing them out. What do you guys think? Okay, I've done that with 125. I think Flamin' Hots, people will do anything for Flamin' Hots, just so you guys know. That's called a transversal. Thank you. Outstanding. That's known as a transversal. We have really the following. You have L1 and L2 are parallel, okay? And so we write it down that way. And then L3 is just kind of another line. And it intersects both. You say, what's an intersection? Well, there's a point of intersection here and here. Do you guys see that? That's an intersection. They just cross. That's an intersection. So this is called a transversal. Now, what's so special about transversals, ladies and gentlemen? You know, it's kind of interesting and it's kind of fun. And I'll tell you guys, these ideas are ancient ideas. Ancient. What do I mean by being ancient? We got to look up the history of this stuff. Since before what? Christ. Ancient. You imagine that, ladies and gentlemen? You're looking at ancient ideas? This is some fundamentals of human reason. This is ancient. L1 parallel to L2, lines that never intersect. And then you have another line and it intersects there, right? Okay, because we've been, as human beings, been wondering about how a lot of things relate and behave. And we start with some fundamental ideas here. So does anybody know? If I said this to you here, I'm going to call this angle alpha, and I'm going to call this angle what? Beta. You guys with me on that? So there's the third line. Well, I know one thing, first of all, although this is kind of not my point, but it's a good observation. What do I know about these two angles? The sum is what? 180, is that right? Good job. They form a straight line. A straight line angle is 180. This whole angle is 180 degrees, ladies and gentlemen. Let's write that down. Forms a straight line. Okay. Now, okay, well, we know that's a straight line. Okay, that's good to know. But here's something you may not know. These two angles are special. Right? Let's see if you guys remember what's so special about those two angles. What is that? Gotta find the right, but I gotta label this thing. What's special about these angles? They are the same. That is true. In other words, they are the same angles, but what do we call that? Do you guys know the formal name for that situation? Well, beta and beta are not adjacent. They have to be next to each other. And in fact, in geometry, there's a lot more formal definitions in geometry, if you guys know what I mean. They'll have like points on a line, and they'll define it a lot more formally than I have. You guys know what I mean? But I want you guys to know one fundamental thing here. Okay? Whenever you have two lines, first of all, are these lines parallel? No. So we got L1, we got L2. What do we know in relation to these two? What is that saying? This is an important detail. This is my parallel sign, but what did I just do? I crossed it out. So what does that mean? It's not parallel. And if you look at it, you go, yeah, I agree with you. But these lines actually have a point of intersection, right? Okay? So here's what I want to remark to you guys. That whenever two lines intersect, there's a special relationship that happens. I can call this alpha and this alpha. And I could call this beta and this beta. But let me not do that yet. They're the same. I'm just going to go back to some very simple symbols. I'm going to say A and B, and I want you guys to understand this little detail. Because you said, Mr. Judge, you just changed the letters, and now I'm confused. Well, here's what I want to say to you guys. Let me go back a little bit into geometry. Give you a definition. We say, and then they'll use this, angle alpha and what? Angle beta. Do you guys remember that kind of stuff? They give you a little angle. And this is how they would really somewhat define it, how you can define it. We say angle alpha and beta are, what do we call those things? They're called different things. They're called opposite angles. And there's another word, vertical what? Angles. If, well, I'll just leave it at, if you see the picture, let's say see picture, if you intersect two lines, and then they'll say the measure of angle alpha equals the measure of angle beta. In other words, they're saying they measure the same angles. So whenever you intersect lines, that's what I mean by see picture. Here's your first line. Here's your second line. What they're saying is that these two angles are the same. Okay? And that's when I started to say to you, hey, I can just describe it very simply as saying this is measuring alpha, this is alpha, and this is the same. These are opposite and vertical angles as well. They're opposite one another when you intersect two lines. So, whenever you intersect two lines, these angles are opposite. So this is some good stuff, ladies and gentlemen. Do you guys remember some of this stuff from geometry, maybe? Do you guys know what I'm saying? Wrong. Okay. Is that clearing out the cobwebs? Yes. Mm-hmm. Well, those are lines. I'm highlighting the lines only. Well, those are angles. Those are like A is the same as alpha, B is the same as beta, but how they describe it initially is this way. They say the measure of angle alpha equals the measure of angle beta. Okay, that's the formal geometry, I should say, notation. M is for measure. Parentheses means of. The angle symbol with the letter is A, and then equal means equal. So when I read it left to right, this is important. You know, when we read, be careful how you read, right? This stuff is, we're doing things in English. And in English, there's a lot of languages that are read left to right. Not always. Some locations in the world, they're read right to left. Some locations in the world, they're read top down. Okay, and then some locations in the world, they're down up. But in English, we read left to right. So when I say, be careful, what am I saying? Measure of angle A equals measure of angle B. Okay, so what they're saying is these two things are the same. I can also put alpha and alpha, and that just summarizes and says, oh, is that the same? Yes. And notice beta and beta is the same too, because they're opposite angles or vertical angles. So this is something very special and fundamental that we define when we actually intersect two lines. Just intersecting two lines, we know these facts. Okay, so clearing out some geometry cobwebs here. Okay, so we kind of need to know a little bit of this stuff because you know what is this course trigonometry? Good. It's like the most useful math course of your life. There's 2 courses. 2 courses are extremely useful. I think every person in the world needs to know 2 math courses. If I was president of the world, you would know 2 math courses. Everybody. Trigonometry is what? One of them. You might say, why do you guys think trigonometry should be a world-known course? Anybody? What do you guys think? I know you don't know this yet, but I might have mentioned it. Right? Why is trig that important? Like 90% of your physical science is based on trigonometry. 90% of the things in physical science is based on trig. So if you want to understand the world around you in a physical way, trig is like your bread and butter. But, you know, before you get there, though, of course, you have geometry, you know, and that's important, you know. Remember, this stuff is ancient. What's the second math course that you think is somewhat usable? I mean, algebra. Algebra is very, you know, it is usable. Where does algebra come from? Where's our wrong one? Where does algebra even come from? Yes, it is from the Middle East. Outstanding. Yes. Well, it's yes, Arabic. Do you guys know that? Algebra is an Arabic word. Algebra. My mother's maiden name is Almanza. You say, but Mr. Judge, that's a Spanish word. Well, my mom's Mexican. Where did she get her name? Well, she got from her parents. But did you guys know the Moors occupied Spain for 1,000 years? That's why in Spanish there's a lot of Arabic words. Anybody live in Alhambra? Who lives in Alhambra? Nobody? Alhambra's an Arabic what word? Do you guys know that? Isn't that interesting? Came from the Moors. Um, it's in the Spanish language. A lot of these words. Al. Is there any other name you guys can think of that starts with Al? Besides algebra, Alhambra, Almanza. What are some other words? Al. Let's think of it. Is it too early? Should we get our. Huh? No, that's EL. But you might be on to, I think it's not just L, it might be Al too. I have to look into that one. I just know the math stuff. Yes. Al what? I'm sorry. I'm so deaf and blind. Aldebaran? Never heard that word. Who's that? Is the song? A star? So what you guys are looking at, here's my point to you guys. I say it's ancient and it comes from what? It really comes from, other parts of the world. It started there. So algebra, yes, is very important. Algebra, we can thank the Middle East for this stuff. Algebra, right? Geometry as well. Some of that comes from geometry too. But the question is always, what civilizations knew what and when? Because there are other civilizations, and the question is, what did they know? Like the Mayans, right? What did the Mayans know? They were pioneers in math and science at one point. They were so advanced, they're more advanced than it's thought of than their peers. And so, the problem with the Mayans, though, is that the Spaniards came and burned everything, and we don't know. And they didn't write everything down either. It was passed on orally. So there's two issues there. The stuff they did write was destroyed. So people always wonder how much of this kind of algebra and geometry did other civilizations know? And there's a lot of research done in that kind of stuff. Your number system, where does your number system come from? Also, it's called a Hindu-Arabic number system. Hindu-Arabic. Where are the Hindus? India. Yeah, so it's also Middle East Asia. Middle East Asia. We owe our number system to. But there's a lot of number systems that have existed throughout the world. The Mayans had their own number system. What we use, the Arabic Hindu number system. And so this stuff has its origins, and it's ancient, and it's everywhere. Okay, so that's kind of the idea, to kind of let you guys know this kind of nice stuff that people have thought of and looked at and go, we're naming this situation vertical opposite angles. They have the same measure. Okay, and then we start to use this. But I digressed, and let's go back. What's the other second most important course? Statistics. Statistics. That way you can learn how and when everybody lies to you. There's a lot of logic, a lot of use in statistics, but people use it to lie all the time. We get lied to a lot, and they try to use statistics, and they say, as a way to, don't even question me, the data says so. Data says this. So it's good to know statistics so you know when they're what? Lying to you. Anyway, just so you guys know, take that home and think about that. Now you might say, what does this have to do with my geometry review, Mr. Judge? Well, can you read what they say here? What do they want you to do? They want you to find the angles. You go, what angles? Well, we can call that alpha. We can call that beta. Here's the first angle, right? Here's the what? The second angle. You got to know a little geometry. Alpha plus beta equals what? 90 degrees. But then what do you guys see here? What is represented with alpha? 2x. What about beta? Yeah. So you go, what are they telling me? Here's the 2x, and then here's the what? X minus 15. So they're giving me now, they say 2x plus x minus 15 equals 90 degrees there. And I'll put the 90. I'll leave the degree out, right? But we understand that means degrees. What are you guys looking at now? What is this? That's a what? That's an equation. Yeah, you're looking at an equation. You see the equal sign in the variable x? So what do you have to do? What do they just say? They want you to solve for x. So how you do that is using, again, algebra. Hit the wrong button, but maybe it makes some sense. Okay, how do we do this? You guys know? You add your like terms. What's 2x plus x? So it's 3x minus 15 equals what? 90. What do you guys do now? Right? Add 15 to both sides, right? And you get now 3x equals, what's 90 plus 15? 105. Okay, is that true? Well, how do we actually solve for x? Divide both sides now by what? 3. What do you guys get for x? What does x equal? 105 divided by 3. Do you guys know a little interesting trick? This, I can look at this, sort of look at it. I could tell you when the answer is going to be a whole number or a decimal. How do I know? There's a trick. What's the trick? Add the digits. Yes. 1, 0, and 5 gives you what? 6. If the sum of the digits is divisible by 3, then so is the number. Do you guys know that trick? Yeah, that's a nice trick. So when I go, okay, 5 plus 0 is 5 plus 1 is 6. 6 divided by 3 is 2. It's divisible, meaning there's no decimal. There's no remainder. So then, yes. You say, well, how do I know this? How do I get the answer? Ladies and gentlemen, let me say this to you. There's no shame in doing arithmetic. In fact, you may want to review arithmetic. So 3 goes into 10 3 times. 3 times 3 is 9. Subtract, you have 1. Bring down the 5. 3 goes into 15 how many times? 5. 5 times 3 is 15. Subtract. There you go. What does x equal? X is 35, ladies and gentlemen. Okay, so you need that step. So we got 35, okay? Solving equations is important. Yeah, if the sum of the digits is divisible by 3, then the number is divisible by 3. Like if I wrote down 1, 1, 1. 1, 1, 1, 1. Is that divisible by 3? Yes. How do you know? 1 plus 1 plus 1 is 3. 3 divides itself with a 0 remainder. I can divide by 3 with no decimal, no remainder. In fact, I can add a 0, 6. I still know it's divisible by 3. I can add a 1, 2, still divisible by 3. You guys see what I'm saying? Add the digits. That's a little trick. If you can't do that, then you'll have a remainder. Just kind of throw that out there. Always good to practice your arithmetic skills. No. Every number has its thing. Like the digit, like how do you know when a number is divisible by 5, by the way? Ends in 5 or 0. Ends in 5 or 0. How do you know when a number is divisible by 2? It ends in an even number or 0. So there's a trick for 4, and I'm trying to remember 4, 6, and 9, blah, blah, blah. Anyway. Interesting stuff. But did you answer the question? Anyway, no. Are you done with this? Oops, wrong one. Wrong one. Wrong one. I'm looking for the right button. Are you done? What do you guys think? Say no. How do you know you're not done? What are they asking? They're asking you for the angles. See, this is what I mean. It's always good to read your instructions. They're asking for the angles. And you go, well, what are the angles? The angles are alpha and beta. So if you go, okay, angles are alpha and beta, well, what is alpha? 2x. I have to replace x with 35. I replace x with 35 for beta, right? So I can say, really, alpha is 2x, beta is x minus 15. How do I find those answers? Substitute. I like that word. It's another algebra-ish exercise. Algebra. Go home and tell your parents, hey, guess what? I think I know where algebra comes from. It comes from the Middle East. X is what value? 35. So what is alpha? 2 times 35 is 70. What's 35 minus 15? What's beta? Is that 20? Guess what you just found? You found the angles. Alpha is 70, beta is 20. How can we check that these are correct? Is 70 plus 20 equal to 90? So, yeah, you found the answers, ladies and gentlemen. What do you guys think? Is that kind of easy or is that hard? I don't know. It's putting a lot of ideas together. It's putting some ideas together. But you want to know something? Anything worthwhile has a lot of ideas that must be put together. Anybody here like video games? Where are the gamers in the room? Probably everybody. What's your favorite game? Anybody here have a favorite game? What is it? Halo? Okay. That's such an old game, though. That's an old game. Halo's pretty old. What Halo number are they up to? Halo 5? Wow. That was like Halo 32 or something. What are they going to do? I guess they're not going to go that far. Halo 32. Is it a worthwhile game? You think it's pretty complicated? Imagine the people that have to program that stuff. You guys know what I'm saying? So you want to master basic fundamental skills, and if you do that, then you can start doing something significant. So something like this involves ideas of geometry and algebra. And, again, you're taking a trig course, it's going to use the same kind of things, algebra and even trig, by the way. Same ideas. So that's why you have to go back and review some of these things. Take a look at this picture, though. Number 9. What do they say here? They even give you a hint. It's the same kind of question. Determine the following what? Supplementary angles? Angles are supplementary? Yeah. Together, they form a what? Here's my first angle, the second angle. Okay. You can call that alpha. You can call that beta. And just to kind of go through some of the symbolism there, forms a straight line. Okay, they're next to each other. They're adjacent. So they're saying x minus 20 plus x plus 12. What should that equal? Well, it's a straight line, so it equals what? 180 degrees. I'm just going to put down 180 because I'm going to get a nice answer that I know will be in degrees. So just to kind of emphasize, here's the alpha by colors, and then here's your beta here, okay? So what should you guys do with these? What do you guys think? They're going to say determine the following supplementary angles by solving for x. You got to solve another algebra equation. So what do you think you're going to get? Combine like terms. You got x minus 20 plus x plus 12. What do you guys get? You're going to combine the x's in that 2x. And then what's this minus 20 plus 12 business? Minus 8. And is that equal to 180? Okay, you guys okay with that? Then what? Add 8. You get 2x becomes 188. Is that true? And then to get x by itself, divide both sides by 2. What do you guys know about this? Am I going to get a nice whole number answer? Yeah, because the last digit is a what? Is an 8. It's a different test. So, okay. What is 188 divided by 2? Right? There is no shame in saying 2 goes into 1. No, 2 goes in 18. 9. 9 times 2 is 18. Subtract. You got 0. Bring down the 8. 2 goes into 8. How many times? 4. 94. So x is 94, ladies and gentlemen. Now, here's the deal. Are you actually done if they said determine the following supplementary angles? Are you done? No, what do you have to do? Substitute. Wherever there's an x, you put what? 94. So alpha here is 94 minus 20. What do you guys know about alpha? What's that going to be? 74 degrees. Okay, and then beta is what? 74 plus 12. What does beta become? 86 degrees? Is that true? 94. Ooh, I got to go get more coffee. You know what I wish I wish this school had a coffee machine. You know, you have to go to the Husky store. Who wants to do that? Do they have anything good at the Husky store? What's good? Peanut butter and jelly? I think so. Anything else good at the Husky store? Since I have to go get some coffee? What's 94 plus 12? 106. Now, I'm going to warn you guys about something here, okay? Which is good to know. It's good to know. We did all the algebra. We used the geometry. Now, when we go back to the picture, okay, what sometimes happens in the picture is that this thing does not make any sense. Why, if I go back and say, numerically we got these answers, why might you say, but Mr. Judge, the picture makes no sense? Does the picture make any sense if you look at this? Makes no sense. Why? Well, what we're saying is this angle we called alpha here, right? This first angle is 74 degrees. That can't be 74 degrees, really. Why? What is that even known as? It's an obtuse angle. What's an obtuse angle? Angle that's actually between 90 and 180. So let's go back to our definition page, because it's good to have some notes. Definition. we say, and then, you know, we always have these issues. What do you use, Greek letters or whatever? Should we change the letters, the Greek letter? Alpha, beta, gamma, theta. We say theta is, what do we say, obtuse? If it's between 0 and 90. Okay, so if it's smaller than a right angle, which is a corner, and corners are everywhere, by the way. If I look up at the ceiling, I see a bunch of corners. Do I see corners in the ceiling? If you guys look at your paper, are there corners? Look at all the geometry you have just by looking at your paper. Parallel lines and corners. 90 degrees. So if an angle is less than 90 degrees, we say it is what? Obtuse. Let's compare that to this other definition. We say theta is, what's the other word? An acute angle. If what? When is it acute? Greater than 90, but less than what? 180. You know, this is a word, acute, not acute. It's acute. So you guys have those definitions. Yes. Excuse me? I don't know. You guys tell me. I'm not awake yet. I don't have my coffee. Is it the other way around? Acute and obtuse. So what I want to say and demonstrate to you guys really is the following, right? You might run across that kind of situation where you say, you know what? Alpha can't be 74 degrees because that's an angle that is, what is that? It's bigger than 90. That's obtuse. And you have this situation where beta is 106 degrees. That has to be bigger than 90, and it's not by the picture. So really what I'm saying is sometimes when you go through the arithmetic, the algebra, and the geometry, you'll get an answer that kind of looks wrong, and that's okay to know too. You go, oh. And that just means whoever wrote some of this stuff wasn't so careful at writing it if their intent was to have it match. Sometimes the intent isn't to have it match. Because sometimes even in physical situations you'll see in your future, like for the law of sines, you have these very funny situations. You got to look back. And even you might even have an application. You got to look back and double check. Does it make sense? So, you know, it's good to be aware, because you have to look back and see if it makes sense just because of the calculations. You know, and that's kind of why sometimes you don't see people who write this stuff necessarily take that kind of care, because it's good to double check. I just want to kind of let you guys know in the beginning with some of these things, you might find that. Okay? Just to let you know. What do you guys think? Is this easy or is this hard? You guys remember some of these things? And you go, well, what about this, Mr. Judge? What is this? You know what you should have? They should tell you. L1, L2 are what? Parallel. Well, I guess they don't have to. Why don't they have to do that? There's a good reason why whoever wrote this, legally, they're okay. Why? What do they say? This is a what? By definition of a transversal, you will have this with the third line going through both. So they're covered because they use the magic word of what? Transversal. If they didn't have the magic word of transversal, we can't assume. Just so you guys know. And if they gave you something like that, well, then you can't really do the exercise. So that's good news. So don't let that sweat you and you go, well, what if they didn't do it? No, if they didn't do it, it was a typo or whatever. So what do we know? How do we get this started? Determine the missing what? Angles. They're all missing, aren't they? And we didn't talk about that other portion, but whatever. Aren't they all missing? Yeah. So how do we start this off? Yeah, first of all, we know something about these two. What do we know? They form a what? Straight angle. So let's do the algebra. Okay, so add your 6. We get 2x is 186. Divide by 2. What is x going to be? I don't know. Did I make another mistake? 2x minus 6 is 180. Add 6, 186 divided by 2. Is that 93 degrees? You guys okay with that? So x is 93. What is this first angle here? If I plug in a 93 now, isn't that 105 degrees? If I plug in a 93, what's 93 minus 18? Is that 75 degrees? So far, so good? You guys get that kind of stuff there in your arithmetic and your algebra? You guys get that? 105 and 90 and 75? All right. Okay. We got that. Good. But you want to know something? Let me erase this. $105. I'm going to put this green, and I'm going to put this what? Orange. Why? Why can I put those colors there? They're opposite angles, aren't they? Or vertical angles. Outstanding. You know what this means also? Measures 105 degrees. And then what does this mean? 75 degrees. Okay. You guys with me on that? Because opposite and vertical angles have the same what again? Measure. They measure the same thing. So far, so good. You guys okay with that one? All right. Here's what I also want to say here. This is why you care about the lines being parallel. There's other angles that are missing. Here, 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 and here. Now, I'm not going to go through all the language of it all. All the language. What do I mean? I'm not going to go through the language of it. You go, what do you mean? I'm going to go through the logic. Okay? What's so nice about the lines being parallel? L1 and L2. Why is that nice? Because we have more missing angles. Why is that a good thing? Anybody have an imagination? Here's what you want to do. Take L1, take L1 and put it over L2. Or put L2 over L1. Use your imagination. I wish I can. I guess I could if I. You don't know what that means? You see this 105? Isn't it right here as well? You see this 75? Isn't it right here as well? You guys see what I'm saying? If I can move L2 over L1, I get the same measures because the lines are parallel. That's why you care. Wrong. Got it. So in other words, you can say this is what, 105, and this is 75. How do I get the remaining answers? There's two ways. You can say, well, isn't this the same as this because we put the lines over each other? Yeah, that's 75. Oh, but they're opposite. Yeah, I know. Or we can say, hey, these are opposite or vertical angles. And so, yes, you should have what now? Orange and then what? Green. And ladies and gentlemen, what do you see here? You have completed the task. You have done what? Found the missing angles by using knowledge of geometry and algebra and arithmetic. Okay, so there you guys go. Trying to find the right one. Yeah, there we go. What do you guys think? Is that easy or is that hard? Is that okay? Sort of okay. All right. Well, anyway, look at this. So, there's a couple of things I wanted to do and say to you guys, I guess. Get you started on some of this stuff. This is on my website. So what I normally do here, you see this assignment here? You guys can watch me do this. It's called homework what? Number 1. And I'm going to call this, geometry what? Review 1. You're going to do the odds. I'm going to have to talk about that phrase. Because I've had people ask me about that phrase. What does it mean if it says do the odds? And by the way, let's go back, okay? Remember our schedule. When is our first test? Can't even see that. Oh, you should be in my browser. When's our first test? September 19th. Let's go back to Canvas. So when I go over here, when I put the, you guys don't know this. I'm going to say it's a file upload. We're going to go PDF. You guys know what I mean? Okay. How many points is that? You guys remember from the syllabus? Isn't that 20 points? Yeah, that's in points. It's online, submission online. Yeah, unlimited tries to try to submit that sometimes. Yeah, we're signing it to everybody. Hey, September what date? Is it September 19th? I got to double check. Sometimes students give me the wrong dates. And sometimes I do it wrong. What time does class start? That's an early class. I talk to the chair. Why are you giving me classes so early like that? They haven't published. So for homework 1, this is not due tomorrow, is it? When is it due? Day of your first test. So every day, for the most part, what I usually do is kind of add to it and add to it and add to it somewhat, as we go along. So homework 1 gets added. This isn't all of homework 1. So even if you complete it tonight, you go, Mr. Judge, I'm completing it tonight. Good for you. Are you going to submit it? No. You got to wait for the other assignments. So when you get the other assignments, put here, and I'll show you. I'll walk you guys through it. I even put it online. Okay, we're going to add Geometry Review 2 now. And we're going to add this now. We're going to add this bookwork. And then it'll be due, right before your test. So don't kind of I'm glad if you do it today, but you don't have to submit it today. Okay, you guys know what I mean? You don't have to submit it. In fact, don't submit it today. I'm going to ask you because you're going to have to do it over anyway because it'll be incomplete. Okay, you see what I'm saying? Okay. And then that's that. But what does odds mean? Because I had to explain to a class last time what odds meant. They didn't know what odds mean. What do odds mean? Only odd numbered questions. Good. What are they? What are the odd numbers? Numbers divisible by 2 that give you a remainder of 1. What does that mean? 1, 3, 5, 7, 9, right? 11, 13. And then people ask this question, Mr. Judge, do you want me to do all the odds? Wrong button again. If you see the word odds, does that mean all the odds? What do you guys think? Yes. But we usually don't say, well, I don't know. It's kind of, I'd have to talk to the English majors. Any English majors in the world, in the room, what does that mean? Do you need to write down the word all the odds? You should just write down do the odds. Not do all the odds. Where are the English majors? What does that mean? It might be called something. Anybody know? I have no idea. But when I put down odds, it's code for all the odds. What are they again? 1, 3, 5, 7, 9, 11. What if you say, Mr. Judge, it ends at 21? Then you end the odds at what? 21. And don't ask me, do I do 23 if it ends at 21? I'll say there's no 23. You guys know what I'm saying? It's kind of how you got to explain that to people. You know, maybe explain it in the beginning and then at the end, you know, people know. But those are the things. So, do you want me to do all the odds? Well, if it says odds, that's code for all the odds. Okay, you guys okay with that? And really, odd numbers are divisible by 2 with a remainder of 1. What are even numbers? Divisible by 2 with a remainder of 0. But in fact, I'm even using bad language again too. Here's the real language. To be divisible implies, well, I guess it's semantics. Who cares? Who cares? We don't need to know that. And also, I updated your what? Your syllabus so it has some accuracy. Right? What kind of class is this again? So you might have to hit refresh. What does it say? Face to what? Face. This is a face-to-face class. Is that right? Well, you say, well, Mr. Judge, why do you broadcast? Well, because in case somebody goes down with COVID or I go down with COVID, we're all set. I found that students appreciate having recorded lectures, so they go back and they can take a look at it, you know? Maybe you can't make it for whatever reason, a lecture. I don't know. There could be any reason you can't make it. Who knows? Maybe you're going to chase your dog or your cat, right? Because the cat ran away in the morning and you go, oh my God, my favorite cat ran away. Okay, you guys know what I mean? Whatever happens in people's lives. So as you guys can see, I'm broadcasting there, right? Okay, you guys see what I'm saying? And so now you guys kind of have a good idea of understanding how things work and how you're doing stuff. And anybody have any questions? Because I think I did want to get to the last portion of the syllabus. Right? Didn't we say we had to get to a few things? What do we have to get through? The class rules? You know what the class rules are? What do you guys think? They're kind of obvious. Talking is prohibited during course instruction and tests, final exam. This distracts the instructor as well as neighboring students, so please be courteous. If you're late, just enter the room what? Quietly and discreetly. You know, this distracts the instructor as well as neighboring students, so please be courteous. Turn off your cell phones or put them on vibrate during class time. That includes me too. This distracts instructors, those neighboring students, so please be courteous. And any student that disrupts the class in any manner by talking, cursing, laughing, or any other way will be warned once and drop from the course if the behavior continues. I will not reinstate you once I've dropped you for behavior. Say that again. What do you mean? What's after 2 weeks? Well, you get a warning. You get a warning. You know, you get warned, and then you get dropped the second time for your behavior. And it'll probably go through a student discipline kind of situation. There's what you guys probably want to know is there's a student code of conduct. That's a board. There's formal things really involved here. You know, and it'll go through those formal practices. I've actually checked with legal counsel on things. Believe it or not, I work with legal counsel in district. There's some things that students should know. It's in the student code of conduct and so on. But yeah, you should kind of know your rights and stuff. But I have had a student. He was a nice guy. He couldn't stop cursing to save his life. You guys know what I mean? Like, here's the kind of things that he would say and do. Should I even go there? Should I even tell you? I don't want to tell you guys. You see how I put the homework? Yeah. Mr. Judge, yeah. Do you really got to do all that schlitz? You guys know what I mean? Couldn't stop cursing to save his life. This is kind of how he was. Just people would get angry and offended. They get upset. So anyway, poor guy. He was not here anymore. Huh? What do you mean? What do you mean personal? It's not a personal thing for me. What happens is the students around you could start to get offended by what you say and do, and if it's over the lines at times, that's kind of the thing about it. It's not about me personally where I say, you're doing things I don't like. It's if there's an issue in a class, who's the first person they actually come to and blame? It's the instructor. So the instructors have to maintain the classroom environment. That's their responsibility. Okay. I think it's okay. No, it's not me personally where I say, because when I go home, you guys don't want to hear me. But I'm not home. Where am I? In class, at work. You're allowed to start cursing at work, you guys think? What do they tell you at work? They get offended. So even myself, I can't do it either. Some people had some questions. I'm sorry. Yes.
The homework submission is available up until...
Yeah, up until that time. Yeah, so you can, yes. Someone else had a question? I'm sorry.
Oh, no, nothing.
Okay, you guys, you are free to go. Take care, stay safe, and have a wonderful day. We'll see you guys later.